Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Melani, and in this video, I will be demonstrating a simulation of an electropneumatic circuit using software FleetSim. This video is made as a part of the final assessment for the Actuators and Drive System course, supervised by Mr. Anugrah Wibisana. The circuit I will be simulating is designed to control two double-acting cylinders with a specific motion sequence: B plus, B min, A plus, and A min. It uses various components such as solenoid valves, relays, and limit switch to achieve automatic movement based on sensor feedback. As you can see on the screen, this is the complete circuit that we will build in the simulation. First, I will select the required components from the library and start assembling the circuit step by step. Okay, this is the complete circuit after all components have been connected. Now I will explain the function of each component and how the circuit operates. Let's begin with the pneumatic components. Okay, here is a compressed air source and service unit. The circuit uses a compressed air source, connect through an air service unit, which includes filter, regulator, and lubricator to condition the air before it enters the system. Okay, next is a 5/2A solenoid valve. In here we have a 1x and 2x, each is a variable name. This directional control valve have 5 ports and 2 positions. They direct the compressed air to either extend or retract the cylinder depending on which solenoid is activated. There is any solenoid for 1x is a 1-way-1 and 1-way-2, and for a 2x is a 2-way-1 and 2-way-2. The solenoids are electrically energized to shift the valve spool, changing the airflow direction to the cylinder. Okay, here is a one-way control valve. These valves control the speed of the cylinder movement. They allow air to flow freely in one direction and restrict flow in the opposite direction to reduce speed and provide smooth motion. And next is a cylinder, double-acting cylinder. This actuator converts compressed air into linear motion. Each cylinder can extend and retract using air pressure on both sides of the piston. The cylinder is used limit switch sensor. There is any LS1, LS2, LS3, and LS4. Okay, let's take a look at the electrical components used in the circuit. The electrical part of the circuit is powered by 24-volt DC supply, which provide energy for relays, solenoids, and sensor. This is our pause button. Pause button start. The start button is used to initiate the operation. It is normally open and only pass current when pressed. The stop button is normally closed and used to break the circuit and stop the entire operation at any time. Relay coils act as electrically controlled switches. When energized, they activate internal contact to allow current to flow to other components such as solenoid valves. And this is a relay contacts. These are part of the relay mechanism. They close or open based on the state of the relay coil, controlling the current path in the circuit. And this is a sensor limit switch contact. We have 4 in here, LS1, LS2, LS3, and LS4. As you guys can see in the screen, before the start button is pressed, the circuit already reacts due to the arrangement of a normally closed contact in the electrical lines. In line 7, the K2 contact is normally closed, allowing current to flow to the solenoids 2-way-2 and 1-way-1. Additionally, LS3 is also a normally closed contact, so the current reaches solenoid 1-way-1, causing cylinder A to extend immediately. As the cylinder A extends, it hits limit switch LS2. This closes the contact in lane 3, activating relay K2. Relay K2 then closes its holding contact in lane 4 and open the normally closed contact in lane 7, stopping the initial flow to 1-way-1. Meanwhile, in line 5, the normally open NO contact of K2 closes, energizing solenoid 1-way-2. This causes cylinder A to retract back to its original position, completing the automatic initial motion before the real sequence begins. And when the start button is pressed, the current flows and energizes relay coil K1. This closes the K1 contact in line 2, functioning as a latching contact, and also closes the K1 contact in line 6, activating solenoid 2-way-1. When cylinder B extends B+, it hits the limit switch LS4. Since LS4 is normally closed, it's open, cutting off the current to relay coil K2. As a result, the K2 contact in line 7, which was previously open, now closes and activates solenoid 2A2, causing cylinder B to retract or B-min. While returning, cylinder B hits limit switch LS3. When LS3 closes, it activates solenoid 1Y1, causing cylinder A to extend or A+. And as the cylinder A moves forward, it triggers limit switch LS2, which activates relay coil K2. This closes the K2 contact in line 5, energizing solenoid 1Y2, causing cylinder A to retract or A-min. The cycle repeats continuously in a motion pattern B+, B-min, A+, and A-min, and it will stop only when the stop button is pressed. Okay, that's the end of my simulation video. I've explained the components used, their function, and how the electropneumatic circuit works with the sequence B+, B-min, A+, and A-min. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.